Hey guys, it's Miss Hale. We are going to be doing a review of decimal multiplication with models. So how they model our decimal multiplication. So I've already done the first one here, so we're just going to talk through it and then we'll do the second and third one together, okay? So I'm not expecting you to write any of this. I just want you to follow along and pay attention, okay? So 5/10 times 2/10 equals 10 hundredths. So let's talk through this hundredths grid first really quickly. So a hundredths grid has 100 pieces in it, so 100 boxes inside. So if we were to kind of think about that like money, the entire hundredths grid would be equivalent to one whole or $1. And then if we wanted to talk about the value of each one of these pieces, well, it's 100th, which is equivalent to a penny. So if we had 100 pennies, of course, we would have $1. Then if we wanted to look at another denomination or another piece of money that we could use to represent this, each row has 10 pennies, or each row or each column, either way, has 10 pennies in it. So when we have 10 pennies, then we have a dime. And then if we were to have 10 dimes, we would have the whole dollar that would be filled up here. So I like to relate this to money because you guys really understand that. You've been working with money for a long time. So going back to our 5/10 times 2/10. So we have 5/10. So we know that 10 hundredths creates 1/10. So we have 1, 2, 3, 4, 5. I've colored those orange. On a paper assignment, it is typically shaded. One would be shaded and the other one would be shaded, and then you end up with a crossover down here, which we'll talk about in a second. Then we have, this is vertically colored, and then horizontally we have our 2/10 colored in blue. And then where those colors cross over, that is actually our answer or our product of this multiplication problem. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 hundredths, which is equivalent to 1/10. So I've also listed out here, you can see that I've not just covered multiplication here, I'm also talking a little bit about division, because this is actually a fact family. We can flip these numbers all around and we still get the same answers. So 2/10 times 5/10 would of course also equal 10 hundredths, which is also equivalent to 1/10. Then we have 1/10 divided by 2/10, which gives us 5/10. And then we have 1/10 divided by 5/10, which would be equivalent to 2/10. So this is a fact family. We can flip these all around. All right, so now let's talk through and work through the next problem together. So we have 3/10 times 4/10. So we're going to vertically color our 3/10. So we have 1, 2, 3. So I'm going to color these in. Remember, that's equivalent to how many cents would this be? That's correct. That would be 30 cents, and we can represent that using 30 pennies or 3 dimes. Very good. And then we have 4/10, which we are going to color horizontally with our blue. So we have 1, 2, 3, 4. 1, 2, 3, and 4. And where those colors cross over is actually our answer or our product to our multiplication problem. So this right here would be our product. All right, so that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hundredths. Okay, so if we were talking money, that would be 12 pennies, or it would be a dime and 2 pennies. And then let's talk through our fact family here. So we have 4/10 times 3/10. So all we've done is just flip those numbers around. It doesn't matter in what order we multiply them, we still get the same answer. Okay, and then we can also take 12 hundredths divided by 3/10, which would give me 4/10. And then we have 12/100 divided by 4/10, which would give me 3/10. Very good. Okay, so we just flip those all around. All right, so now let's move on to our multiplication of a decimal number and a whole number. So this looks a little bit different. Basically, this is repeated addition, and we're going to represent that with our colors. So instead of doing vertically and horizontally coloring, we're actually going to alternate our colors. So we have 25/100, which would be equivalent to, well, of course, this is 25 cents, which is equivalent to 25/100, which would be a 25 pennies. It could be 2 dimes and 1 nickel, and it could also be just a quarter, right? So we know that we have 2 in the tenths place, so we need 2/10. And then we have 5 in the hundredths place, so we know that we're going to color 5 hundredths. 1, 2, 3, 4, 5. Okay, and then I'm going to take my blue and I'm going to color it again. It's repeated addition. It's happening 5 times. So then I'm going to color my 2/10 and my 5/100. I'm going to do this again. And the pattern just continues for 5 times, because that's what I'm multiplying by. Now, what just happened when I colored in all of the hundredths? That's correct. I just created 1 whole and actually $1. Very good, guys. I know you had the right answer to that. All right, and then I have my last 25/100, so I can count and make sure 1, 2, 3, 4, and 5. So I have 25 cents or 25/100 happening 5 times. And this is how it would be represented in my model. So let's write our fact family for this. So we would have, this equals, that would be helpful, $1.25 or 1/25. So then we could also represent this. We could flip it where the whole number doesn't change the value. It is still $1.25. And then we could also do $1.25 divided by 25 cents would give me 5 groups. So then that would be my groups. How many groups did I create of 25 cents? Well, 1, 2, 3, 4, 5. And then I could also do $1.25 divided by 5, which equals 25 cents in each group. Okay, so that is how your fact family works for your decimal multiplication with a whole number. All right, guys, great job today.